This section is titled as LTE Protocol Stack. In this section, we are going to take into account the different protocols and different layers that are involved in the LTE system. And we are going to talk about the different layers and the relevant protocols. So this picture here shows the protocol stack in LTE. As you can see, we have divided it into two parts. We have the EU-TRAN part up until here, and then we have the EPC part from that point on. Now you have the UE that's represented here. You have the E node B that's represented in this section, and you have the MME that's represented up here, and the serving gateway and the P gateway in these two boxes. So let's start by going through from left to right through each of these sections and talk about the different protocols that are involved. So starting off with the UE has this protocol stack defined. You start off with the physical MAC radio link control, or RLC, packet data convergence protocol, or PDCP. You have the radio resource control, the RRC, and then you have the NAS, non-access stratum. So the NAS is probably the one that you are familiar with up until now, since we talked about NAS in the previous sections. Let's talk about some of the others here. On the E node B side, you have the same set of protocols, right? On these layers, but in addition, you have some higher level functionality that's built in. So protocol, first of all, let's first see what a protocol is. So protocol is sort of like a common language that two network entities communicate to each other in at a given layer. So if you guys are familiar with the networking model, say OSI model, or the TCP/IP model, there are multiple layers within those models. So, for example, the OSI model, you have the different layers, and each of those layers has a given set of protocols, and those protocols are it's sort of like a language that those layers can talk to the corresponding layers on the next hop. So you have so there is the layered model here, and then you have these protocols that run between the same layers across two different hosts, essentially. So the UE and the E node B, on a physical layer, they would talk via the physical protocol. On the MAC, the protocols that would be used would be the MAC layer protocols, and so on and so forth. On the RRC, the radio resource control protocol is used to talk at this layer, layer 3. Essentially, this is layer 3. So in the E node B, some of these higher level functions are higher up in the protocol stack, and like intercell radio resource management, radio bearer control, we have connection mobility control, we have admission control, we have E node B measurement, configuration, and provisioning. We have some resource allocation scheduler. So these are just internal to the E node B. There are no mappings for these layers out to any of the network elements. This is just something that is built into the E node B, whereas these there is a corresponding implementation or layer on the UE side. So that's about the EU-TRAN piece. Now on the MME side, or the EPC, you have of course you have the NAS connection between the MME and the UE on the NAS layer, and then you have some responsibilities of the MME here, and these eNode B and MME communicate by the S1 MME protocol, which we'll look at in a later section. Yeah, that's about the MME. The HDW is we talked about. It's a mobility anchor for the most part, and it talks to the eNode B by the S1U interface protocol, and then the P gateway is here. So the intention of this this picture here is to just show you the different layers that are involved in the protocol stack on each of the network elements, in a sense, and kind of give you like a mapping of those protocol layers between the network elements. So here, this is more of some background information that we need to understand before we can keep moving forward. So there are two aspects in a TCP/IP model. There is protocol data units and there are service data units, SDUs. On the transmit side, so this is the transmit side and this is the receive side. So as it's an all IP packet based infrastructure, your on the transmit side, your packets get passed on from layer 4 to layer 3 to 1. They get transmitted, and then on the receiver they are received by 1, passed on to 2, 3, and 4. So again, this is the transmitter, this is the receiver. Now, on the transmit side, packets are transferred from layer n to n-1, so 4 to 3, right? And so on and so forth. At a given layer, n-1 data received from layer n is treated as service data unit. Layer n adds header information to the SDU. The new packet is then referred to as protocol data unit. So let's examine this. So say you are at layer 4. Now, you may have received a packet from 5, data, and that there is your SDU part here. And then layer 4 adds some header. In this case, it adds some TCP header, and then the combined packet is called a PDU. Then this gets pushed down to layer 3. Layer 3 treats this packet as the SDU. That's why it's called layer 3 SDU. It adds an IP header with the source and destination and whatnot. And then this composed packet is now called a layer 3 PDU. This gets pushed down further to layer 2, which is the Ethernet or the MAC layer. And the MAC layer adds a bunch of more header information. And then this combined packet is called the layer 2 PDU, and then this layer 2 PDU is then transferred here. It's received at layer 1. Layer 2 receives it. It strips off the header information and then passes on to layer 3, where layer 3 header is stripped off and passes on to layer 4, and so on and so forth. So as you can see, there is encapsulation of data happening, and then decapsulation as it's being transmitted from a transmitter to receiver. So you just need to be familiar with these two terms, PDUs and SDUs, since they are pretty useful when you are looking at Wireshark traces or captures on the network side, and for troubleshooting and just for better understanding. So on this slide, what we have shown is you have the OSI 7-layer network model here, which is probably familiar to you. You have the physical layer, data link, network, transport, session, presentation, and application. And what this picture here shows you is how the first 3 layers, these 3 layers are mapped to the LTE protocol. And we have layer 1, layer 2, layer 3, and on layer 1 we have the physical, and then layer 2 we have the MAC, radio link control, and PDCP, and layer 3 is the RRC. So what we have essentially done is we have taken the OSI model, and what 3GPP did was it broke out within each of these layers what the different protocols are, and in some cases it actually split the layer into multiple protocols, like you can see here in layer 2. And as you can see, we have the NAS and IP protocol at the highest layer. So the IP packets make their way into the PDCP, and the PDCP communicates with the RLC, which in turn is the MAC, and the sends it to the MAC and the physical, and they get transmitted. And now there is communication between some of these layers and the underlying layer. So you can see there is RRC PDUs are passed on to the PDCP, and the PDCP encapsulates them and it transmits them. But there's a lot of a tight coordination happening between each of these layers. So this picture just wants to give you on how the different layers interact with each other. So hopefully by now you have a decent understanding of the protocol stack in LTE, and you have a sense of what different protocols are involved and how the layers are organized in the different network elements. Since this information is going to be useful as we move through some of the other sections.